class is in the middle between the user and the hardware. So without software, without program, without operating system, we cannot use the hardware service. So that is the main purpose of the operating system. From that point of view, so we have seen the services provided by the operating system. As you know, most of the users know the interface part. We have a graphical user interface, we have a command line interface. Especially I emphasize on the using command line interface. That is close to it's not actually the user-friendly interface. It's more like for the operating system. But as the computer science major, I encourage you guys to learn about the command line. Then that might be much easier and save your life in a computer and IT. And nowadays we have a touch screen interface. It's mostly basically the fingering. So these are the user interface. User interface is one of the important area of computer science. So it's called the HCI, Human Computer Interaction. So then who knows, later we are not going to use even touch, just the voice only. But the voice recognition is already being used as an interface, so we can add Alex, using the Alexa, so we can use the Amazon service. So also we may use the hologram like this for the display, so you don't have to come to here, we don't have to use it. So instead, if you join the classroom, my hologram will be pop up and explain to. So this will be, it's already done in terms of the technology and algorithm, but it's a business model they are thinking, holding their service for the future. Then, so today the last class we talked about the little bit system core. System core is we have such a bunch of services. So today we are not going to cover each and everything today. So just I want to remind you. So we have such the services like the program execution. That is the major part of the operating system to start the program, to create the program, and also manage the I/O and file system and so on. So these are the services provided by the operating system. We will very briefly touch what are they, what of each service today, but we are not going to discuss the details right now. Then we will start from the process management, process execution, probably hopefully today, but not we are going to start from the next class, so to learn about this. But all of these services are, so what if I'd like to create a program that deals with the I/O operation? So how can I use such an operating system service? At that time, operating system provides a programming interface. So in other words, API. So we are going to consider the operating system service as an application that the operating system OS provides the API, the function or library, which is called the system library. Then, when you create the program to write the file, you don't have to know all the things about the hardware. Definitely you should do that if there's nothing. So you need to start from the hardware, device driver, and so on. Interrupt, you need to consider everything. However, so you don't have to do that. Instead, the operating system provide the library function. So for example, in case of the I/O operation, read is a very popular system library. So you can just call such a system library read. Then you don't have to execute even the read. Just ask to your operating system. Because of that, we learned about the dual mode operating system. So if you are running your own application code, that's running on the user mode. But once you call the system library, like the read or write, then your operating system mode is changed to the kernel mode. Then your operating system is in charge of running such a system library. After your operating system read the data and pass the return data to the user, then your application is resumed. then complete your application. So that is the reason system course is in between the user, application, and the services. So this is the dual mode. Because of that, we have the mode bit and change it, the kernel mode, like that. Okay, these are the overview of our operating system. Then still not very familiar with this interface. How can I move? Oh, change this. Okay, so we learned, we have seen such a command line interface. If you do not know anything about the command line interface, why don't you start from the bash shell, the BASH, the bash shell. Oops. Like there are a bunch of different such a command line interface, which is called the shell programming. So C shell, K shell, Cont shell, just the shell. So a bunch of them. Among them, most popular one is the bone shell. But someone little bit enhanced the bone shell. Based on the bone shell, there is the bone again shell, so which is called the bash shell. So right now, most popular the shell programming is the bash shell. And even the Mac OS, adapt the bash shell, but they call the rename the bash shell as the G shell. But they are almost identical. So if you do not know the shell program, you are going to start with the bash shell. So we are going to learn such a bash shell during the exercise lab also. But not much different from it's mostly similar, but C shell, bone shell, they have a different command and a lot of command, but a little bit different programming interface, which is called the shell programming. So then I think it's much easier than the Python or C or such object-oriented programming, so you can easily use and be familiar with that. So this is the screenshot of the, where's my mouse? Oh, here. And I don't want to spend a lot of time to explain the graphical user interface to you because you already familiar with that, but it's worthwhile to know the history of the graphical user interface starting from the Xerox and then this one. So for fun, why don't you read the article that I linked below here. So it's hidden by the menu bar, but you can find the link. Then it's worthwhile just one time. But surprisingly, the early GUI is still being used. So display and the keyboard and the mouse, using mouse pointer, we are going to access this. Pretty much the same interface. Then there has been the improved and nice and neat. This is the current Aqua, the GUI used in the Mac OS. And then we have the newbie, that is the touch screen interface. The touch screen basically based on the tile style and the fingertip, the touch and swipe. So this is the change, such an interface, human-computer interaction changes the GUI, the environment. Then that change also the operating system architecture. We are not going to discuss the details of that mobile operating system, but very briefly see what is the idea of the mobile operating system. So this is the system code that we discussed last time. Keep in mind there are two main types of the system code, the library. One is the Win32 API. Obviously, it's for Windows. So if you are using C++ or the .NET or C#, so such the Microsoft-oriented programming, so you can use the Win32 API. Okay? And on the other hand, when we are talking about the system library or system code, are you able to do the system programming, or do you have the experience on the system programming? At that time, it's called mostly POSIX. The API. So it's used in the Linux or Unix, even the Mac OS. use such a POSIX API. It's for the C or C++ library. It makes sense because what program language are you using when you develop the operating system? It has been changing, but nowadays the low-level part is based on what? Assembly language or PL1. So sometimes called the PL1. Assembly language will be used. And on top of that, so if you want to develop your operating system with the assembly language only, it's really very, very tough. So assembly language mostly deal with the hardware part, then they provide some basic library, then create the library, system library, then on top of that, so you are going to implement your operating system, mostly C or C++ nowadays. Then on top of that, we have, for example, Android are using Java. And then, so some high-level program language also contribute the operating system. So it's not only the single program language. Instead, we are using the multiple program language to develop the operating system. At that time, because a lot part of the operating system coded by the C or C++, so POSIX, like the POSIX API is a C or C++ library. So how many library, how many functions do they provide? It's not huge number. It's not like the 1,000, 10,000 function. Instead, it's very limited. So usually the POSIX API provide, POSIX Win32 API, they provide 100 to less than 200 the function. With such a number of function library, you can do all the things. But question is, I never used such a system library before, which is required, but I never seen. So for example, here, so this is an example of the system, the library used in the Linux, but you can see some of the popular ones. So for example, here we have a fork and exec, read, write, open, and close the PID. But I never used directly this one. You are able to, but you didn't. Why? Your program language has also API. Yeah. So instead of using read, so your program or the write, your program language has a printf. Well, print in Python, you can print the variable in the memory. Then when you print is the user mode. Then when you use the print, so Python, who developed the Python, use the write, the system code. Then the operating system mode is changed to the kernel. Then your kernel will execute the write system code. Then after write, there might be return code. It's okay. Then return to your application program, Python program. Then it's a display like that. So this is how it works with. Because of that, you never see this one. However, nowadays more and more, the company, they want to use the system library directly. So you can customize, it can be efficient. So they ask like when you search the job description, when you search your job, they may ask +3 years of the system programming or the Unix programming. So like that. At that time, the difference is whether or not you are able to use the system library directly. Good news, it's not very complicated. It's mostly because most of the system programming, the Unix programming should be compact and efficient. So it's not 1,000 code. Mostly it's less than the 100 lines of code, or sometimes the 10 lines, the 5 lines. They're very simple because efficiency is important. And the Unix, the system programming. So in the project one, you are going to practice the system programming using such a system library to implement the shell program. So we will discuss more about that later. So in this case, it has how many of them? It's 100, one more page, yes. So 190. So if you are not sure the such a thing, think about the very simple processor. What embedded the processor, embedded system. Embedded operating system also provides such an API. At that time, their library is the number of library is less than 10. Because, for example, this is a remote control. Remote control uses the 4-bit processor, for example. So 4-bit processor also has a number of instructions. Based on that, there are a number of APIs. So using that, you can do this embedded program. Like that. Even they are following the same mechanism, same architecture of the operating system. This is an example of one. Can you see the code? Then guess what program is for the purpose of this program?
Copying one file to another.
Yes, right. This is the system programming of what? CP command. Copy or the CP command. You can guess, even open the file, then test whether the file are valid. If there is no source file, it should be error, right? Then if that is okay, and the destination open, then send the file from read and write, right? Read and write. You can see then close the file, close the file. It's the actually system programming of CP command. If you ever use the CP command on your command line, this is it. Very simple. So this is the system programming. If it is required in your job, so if you are able to use the this is a highlighted one. This is the system library. Okay. So and as you can see, it's not very complicated. Application program mostly the algorithm is more important. Right? If then else or the design, object-oriented design, which will be the data, which will be the method, like that. But on the other hand, the system programming is efficiency directly serve the problem. Okay? It's not application library. So this is an example of the C programming to implement the copy using the system library. And what about this one? It's the same thing, but with Win32 API. So it's the same thing, but as you can see, Win32 API is a more intuitive name. So create file, or create the file, so you can imagine read the file. Unlike the POSIX API, so their name is a more higher level. They simplify such a system programming. So you are able to use such a Win32 API if you are familiar with Windows oriented programming. So I already discussed about the system core implementation. So in other words, when somebody developed, so if I were asked by my manager, why don't you make a new operating system? So at that time, I need to, there are a bunch of things also. I should design what service my operating system provide to user. Then at the time, such a number of system library, system core function will be implemented. So this slide shows the summary of what I introduced. So you can see that this is your program. I got it. And this is your operating system. So for example, if you print, I'd like to use the printf in C or C++ program. Probably printf is not the name of system library. So in the system, everything is write something, right? Device, I/O device, right? So we can use the write. I don't know why I cannot see. So write. So then you are going to the program is currently user mode and changes to the kernel mode. Then the write something. After that, it will back to the user mode. This is the basic. This will happen a lot. The back and forth in your programming. Where is it? So at that time, the problem is the parameter. So I'd like to print hello world. Then how does a kernel know that hello world? Okay. So there are different ways to communicate between application user mode and kernel mode. So can you guess how, if you are asked to develop the architecture, how can you pass? So you have the system library already, right? Then how does your application program and your kernel operating system communicate? In other words, how do you send such a hello world to the kernel? What will be the best way? It's the data, right?
Yeah.
Where do you put the data?
On the memory. In the RAM.
Memory? What the memory?
In the primary memory.
So, for example, when CPU read the data from memory,
Yes.
so CPU directly read the data from the memory, then the calculate and do something.
No,
Is
it
that
has to go to the registers.
Yeah.
register,
Yes.
right? So first way is you can use a register. That's the fastest way and the easy way. So you can use the directly register. In other words, you can put hello world in somewhere in your data register. Problem?
You only have limited registers.
Limited.
Yeah.
So you cannot directly use for example, hello world 100 times, the millionth time. So you cannot put all such a data. How can you address that? Second method.
Put it in the RAM.
That means register has the address of the memory. So that is the second way. So even though we use such a way a lot during the microprocessor assembly program, right? So when you move does not move only the data. You can actually the address of the memory. So then that is the most popular one. Another third way is, as you suggest, you can directly use the memory, something shared area. So always the application program put the data on the specific area of the memory. This is a shared room of our entire UV memory. Then always when the user mode and kernel mode communicate, we use this room. So kernel even return the data to the user using this shared memory. So there are three major ways for the communication. Then the types of a system call. The first most important part is the process control. So we can create the process and terminate the process and monitor the process and something process. This is the first time. So in the project 1, you are going to create the process and terminate the process. That is the 99% of your project 1 using system library. Can I do that? It's less than 10 lines of code to create the process. You are going to add some decoration like the bash shell. Okay, so that is the thing. Then also, unlike your programming, the interface like the Python system, in case something happened in the kernel mode, you don't know what happened. So even the system library, system code provide a function to debug what trace, the memory address. Mostly it's low level, the tracing low level debugging. Sometimes if you have experience on the core dump, the C programming, core dump. What is a core dump? It's a memory dump. So they provide something, in case of something error, it's pointing different address. They actually create the memory dump. It's called the core dump. Then some of the operating system, when you see the output of core dump, you don't understand. It's just a bunch of number and a weird character. Instead, they provide the program system library to understand where is the problem and so on. So that is also type of the the system call. Definitely file management, like the open file, closed file, send data. So these are used for the file management, the Unix command, like the cp, move, and so on. And also the device management, as we have seen during the first chapter, computer, we can regard the computer as a bunch of I/O device. It's an all I/O device. So which means any the device, CPU, memory, the disk drive, and even the display, it's I/O device. Which means, so can we manage the I/O device? How? So system library is help you guys to, if there's a new device, such as input and output, so you can use such a system library. Okay. Then when you develop or when you create a new device, or when you purchase a new device which is not comparable with the operating system, you can do the device programming. Driver, you can create do the programming to create the driver. Mostly it's the I/O match. So like think about the Arduino or the Raspberry Pi. So when you are doing the digital circuit, so where's the input? From the sensor, input data, output data. For example, if we are using the serial, so TX, RX can be used. So you can just byte by byte read the data from TX and send the data, TX send the data, and RX receive the data, like that. So mostly I/O, the control. Okay, how can you find such the I/O control? So for example, this is a VGA 19 pin. So each pin is assigned for the specific purpose. So if I connect this one, then you can read the data. So from the number 1 pin, number 2 pin, and then not all of them are used. Then you can send the data, so you can control. You can make your device program using system library. So this is another types of the system code, and some information, and communication is also we will see later. So we are not going to create the operating system with a single application. It's a multi-programming operating system. So multiple processes are running. They are working sometimes together. How are they communicate each other? Okay? So that is a communication. It's not very complicated. So you can use even network programming in network. So you have used a socket program. Socket program is TCP/IP based. So you can create the socket and send the data, receive the data using IP address and port number. So that is also a popular way in current operating system for the communication between and among the processes. Also, most popular one is you can create a pipe, like the dedicated line. So you can send the data using the pipe and receive the data pipe. And also, you can use the shared memory. So shared root. So put the data on the shared memory and thus receive the data using the shared memory. So that is the shared memory model. We will see more details during the process management, how they connect to each other, which is called the yes. So really hard to control. Oh yes, it's called the IPC. So inter-process communication. So IPC has several ways using memory, shared memory, and also using pipe, and then you can use the socket program, the network program for the communication. Okay, and rotation. So this is a comparison chart between the Windows Win32 API and the Unix API, the POSIX API. So, for example, to create the process, the POSIX API, Unix API uses fork and exec, not exit, exec. Fork plus exec. We will discuss a lot how they are working. So fork and exec. So you heard about probably. So to create a process, operating system use fork and exec. But the Win32 API use the create process. This is the different name of the Windows 32 API. Okay, so I already explained the example of using the printf or the print in terms of dual mode and as well as the system library. So this and based on the system library and so on, so we are going to briefly see some examples of the operating system. The first one is the MS-DOS. Have you ever used the MS-DOS or have you ever seen? So when I learned a computer first time, so with the Windows, so at the time the Microsoft Windows 3.1 has the MS-DOS also inside of Windows. Windows is operating system, but Windows is actually basically based on the MS-DOS. Then the extend and then put the new operating system based on the Windows, and that is the Windows 3.1. Problem? Two operating system. It's like the two family under the same roof. So they are fighting each other. That caused the problem. Later, MS-DOS was retired. But so MS-DOS is basically based on the single program operating system, which means so in the for example here. So this is the memory. Okay. So it's a lower address 0000 and the higher address FFFF. So when you run the command on your MS-DOS, so command will be loaded into the memory like this. Then if you type the command, this one will be out and new command will be created on the memory. It's always swap in and out using the memory. So it's a single program, the operating system. What about the Arduino? Arduino is basically very similar because we have a limited resource on the mobile device. So you need to, what is the most important part of the operating system when you develop on mobile device? What will it be? What you guys need to consider when memory? Memory is also limited, so we should power. Power is the first one. So the most difficult, the better that you overcome when you design any application or even operating system using mobile device is the power. In other words, so if you have the new battery that lasts the 30 days, even not 30 days, a week, you will be super rich. I think that you definitely the top 10, within top 10. So that is the most difficult part. That is the reason still the testing is not easy. Technically it's okay, but it consumes a lot the energy. Why? Because it uses a lot the resource, so that consumes a lot. The second thing is also related interface. Mobile device, so you need to consider the interface. Then the third one, limited resource. Because it's a mobile device thinner and thinner and smaller and smaller, lighter and lighter, so you cannot have the huge size of the device. So like the laptop or the desktop, so that is the thing. So because of that, so it's very similar as MS-DOS to save the resource on the memory. And this is a BSD Berkeley, the branch, the operating system. Okay, as you can see, right now there's a multi-process are running. Okay. So these are the services that are provided by the operating system. I'm going to skip this part. I already explained. Sometimes we call the background process, which is service program, service. Okay. So in other words, when you start your operating system, bunch of processes are created. These are required. You are scared when you turn on your task manager, then to disable some of the services, right? So if the PC is getting slow, you probably search the internet, how can I make my laptop efficient? And there are a bunch of the article to disable this one, to disable this one, but you are scared. That's reasonable. Why? Because they are mostly the system, the background services. But the problem is you are not going to use all the services, right? For example, think about the service provided by the UB or the university. Do you know all the services? Probably not. But that doesn't mean that you are not going to use, ignore that. So because of that, you still turn on that. So that is the system service. Okay? Another, we will discuss later more, the linker and loader. To explain the role of the linker and loader, link and load. So I think the best way is this part. So if you are, let me stop. If I post the screen share, the user can see the camera, right? Anyone who log on the Zoom?
I think so.
Yeah,
But
right?
If they see your, if you
They
stop
can
sharing,
see the camera, right?
if you
So,
stop
yeah.
sharing, they will see it.
So I don't have to change it. So this is the typical process of from development of your application program until the run, execute the program. First, you are going to code. It's a main.c file. Whatever the program language you use, in this case it's a C, the program language. So you have a source code. This is called the source. It's a text file. Then you can compile. For example, we can use the GCC. So GCC minus C, the main.c, minus C option create what? Object file. So object file is not executable file, but this is the translated, compiled into based on the machine language. It's the instruction. Then this one cannot be executed, even though this is the translated, compiled one object file. It cannot be run. For example, if you are using the print F inside, print F, where's the who probably developed the print F? So it's the stdio, the header file. So there might be library. Somebody already implemented this one. So you need this code. Otherwise, you cannot run the program. At that time, you can the link. Link is if there is a standard IO library, IO L, IO library, you are going to include L minus LN. Minus L is the library, share the library and so on. So then finally it can be it can have all the object file, and this is called the link. Okay, make the executable file. Then where is it? The main file. Where is the executable file? This is on your file system, hard disk drive, not on the memory. So to running execution of your program means load such a code into the memory. Okay. So this is called the creating process. This is called the execution. This is the run, whatever the name is. The operating system move the code, this main code, into your memory. Okay. At that time, who is in charge of that? Loader. So loader is a load, copy, move, eventually execute. Okay. Make your program executable. Okay. On your memory. Then finally, CPU can access your code, the one by one, instruction by instruction, that will be executed. So this is the link, and this is the loader. The operating system provides such a link program and load program when they develop the operating system. And then sometimes even though I do not include the link or the library, it runs. How? Such a library is already on your memory. It's called a shared library. I'm not the only one who uses this. Instead, other process can use this. You don't have to link. Instead, dynamic link. So, for example, Windows is called a DLL. File is a dynamic link, the library. So then, what's the benefit? You can save the memory space. So, but your program will be compact, smaller. But if you link static means you actually include this library inside your main executable file. It's larger and takes a longer time. But you don't have to share with the others. It's your own. So some critical application, you are going to use a static link. Otherwise, mostly share the link. Okay, so this is the linker and the loader. Okay, so when you design, hopefully some of you are going to design and implement the new version of operating system and so on. The first step is always, do you need? You need to clarify the need, requirement of your operating system. But there are two perspectives. One is from user side, because the user of the consumer of your operating system is users. So user side, convenient and nice and easy to access. However, eventually operating system will take care of what? Hardware resource. So computer point of view, what is the most important thing? Utilization and performance and such a thing. So always is a conflict. User perspective and the computer perspective is a conflict. So you need to address this one when you design the operating system. That is the different. Application program only for mostly, not only, mostly user side. Okay? But the operating system itself, you need to consider both of them. So, finally, when you implement your operating system, we are going to use mostly C or C++. Nowadays, the mobile operating system like Android, for example, is based on Java. So, such a thing. But the C or C++. But you can see the C or C++, some script language like the Perl to support the system library. Okay? This is the kind of tricky. So OS does provide the C or C++ or Win32 API to the application. This Perl actually implement their own fake library, system like their own library based on this one. Then the user application can use this library like that. Python has also. So in your Tom project, you are able to definitely use C, C++, or some of C# may be possible. So you can use such a program language. And plus Python, Perl is also possible because they provide a system library. However, Java is different because Java is entirely based on what? Virtual machine. This is one process. If you create another process, another program based on Java, it's not actually process. It's inside the Java virtual machine process, it will be thread. All Java applications are threads under virtual machine. So when you list the process, only Java virtual machine, JVM, will be shown. No matter what program the Java application you run, it's inside the virtual machine, it's called a thread. So that is the reason, except the Java. Java is not, doesn't make sense to get used the system program. So, but C, C++, or the C# and other the Windows, if you are using Windows 32 API, you can use, or you can use Python, you can use Perl, even you can use the Windows, Linux-based using the Turbo C or other C, so you can use the POSIX system API. All these are possible for your. So, and if you want to use other program languages like the Ruby or the Julia, which I'm not very familiar, we are going, you'd better contact me whether this language is possible. I'm going to check whether they provide Perl or Python like the system library. So for example, the Python has the package like the OS. So os.fork, so you can create the process. Then this one definitely hold the fork on the C, like this one. I already mentioned, I learned the long time before. So Unix is the most popular operating system. Even the part of the Mac OS is based on the BSD. You can see the BSD over here. Kind of family tree of the Unix system, starting from the 69. So that's the reason the officially being used the first time, the 1970. So when you change the battery on your laptop, so there's a laptop, and there's a small battery inside your computer, which make your computer keep the important data like the date and time and password and so on. So that if you replace that battery, mostly it's reset to the 1970 like that. Unless your operating firmware use the ROM, but mostly not. So it's the 1970 January 1st, the 0000. It's you may not see the 69 or 68 like that. Or sometimes you may see when you are using the Linux or the Unix system, your date is 1970 set to such a thing because of the history. So some of the operating system is monolithic, which means it's one, like the MS-DOS. But like the Unix system, we have seen a lot. So this is the device hardware level and the user level, and they are supported as a service. And the Linux system is the same thing. So basically, as you can see, it's very similar, the modular approach. Some of the operating systems use a layered approach. The layered approach means, so we have the hardware part, so implement, so like the only device, then the system library, and the application, and the kernel, like this, the approach is modular. The benefit is secure, so the user may not access this one. So only the layer by layer, so they can communicate. That is the shortcoming, the drawback of such a layered approach. You need to communicate the layer and the layered program communicate each other. So why don't we put, because inside the layer is important, why don't you put the most important core part of the core library of your operating system as a kernel? Okay, it's a micro kernel. So only the important core, the part will be the created as a kernel, which is called the micro kernel. So macOS uses such approach. The micro kernel, it's called the Mahu. So Mahu is the name of such a micro kernel used in the macOS. So also it's called the Darwin. So you heard about the name of Darwin. If you are using the macOS. Okay. Nowadays, it's more like the modular approach. So like the Sun, Solaris use such approach. So they actually sold module by module. So this is a real story. When I worked for the company as the database administrator, we purchased a Sun microsystem operating system. Sun is 5.6 like that. Then at that time, the purchasing department forget to order the module. So when we purchased that, there is no file system. When we contact the customer service at the time, it's 20 years ago. They said you should have the file system. No way to use. So we need to order again. Then they send the disk, then the install, then finally use that. So module by module they sort. But not only because there is a business model, but also the modularity approach is the good for the. We don't have to get all the operating system. Instead, what we need. So we can just add what we need. So it's a need-based approach. Most of them are hybrid. They mixed up the approach like the macOS. So macOS is based on the microkernel. They have the BSD. They add Mahu, their own kernel, and add the BSD, the Unix system. That's the reason I like to use the features provided by the BSD Unix module than this one. So microkernel is here. So they had the services, and they have the system call that through the POSIX. So we can use, in other words, we can use the POSIX, the system library, for the application program also, because they provide the system call interface. And also they have the Xcode like that. So this is a Darwin architecture, and Android is based on the Linux kernel, but the front-end part is based on the Java. So we can, if we are doing the Android programming, we don't have to worry about this one, only the Java application that will be used. That is the interface module. Okay? And they have something different like the SQLite for data management. So they use the SQLite, the library. But if I'm interested in the kernel or the operating system. So when you start, so like this is the change. So this is my the terminal on my MacBook. So if you type the uname -a on any Linux system or let me increase. Okay. So like this one. So you can see the Darwin is a common name. So this the operating system, the name as Darwin. Then some more Darwin kernel version 1960 like that. If we are using the Linux, we will see such a same example of the command uname -a. At the time when we create the virtual machine on the GCP, it will show the kernel, the Linux kernel, the version 2.6 or the 2.7 like that. Okay? So if you are interested, you can go to the kernel.org, then you can download the code, the source code. Then follow the direction like this, make, and then you can create the VM Linux is the name of kernel. So VM Linux, the name of kernel. So if you add, I have a new algorithm for CPU scheduling. You can replace or add such your algorithm, then rebuild your kernel, then use it. Then how can we use once you rebuild such a Linux kernel or the operating system kernel? How can you use or test the kernel, operating system kernel? It's a program, right? Yeah. Kernel is the first program. It's like any other program. But it should be called first time.
Yes,
Who knows?
the bootloader.
Bootloader. So BIOS program so knows where is location, address of the program, and finally you can test. There are programs to select if you have a multiple corner. I have used a lot until the VMware virtual machine was popular. So we installed multiple operating system and different location. So this room is for the Linux, another room is for the Windows, another room is for the Red Hat Unix. Then when you start the program like the bootloader or there's the group group program. So you can select your operating system. So that is the system boot. So system boot, as we have seen before, is actually the bootstrap loader or BIOS and APROM. So that point where is the operating system. So like the bootstrap, the group can be used to select in case you have multiple. Nowadays, we don't use a lot. Why? VMware. We don't have to manage the 2, 3 multiple. Problem is, if I switch, I need to shut down and start this one. But if we are using virtual machine software, while you are running primary, then you can run the secondary or even, as long as the computer allow the resource, then you can use multiple. Okay. The debugging, I'm going to this part. Okay, that's the end of the chapter 2. Finally, we are going to start this one. Okay, chapter 3. So, process management. So, from now on, so we are going to cover 3 major parts. One is process management, second, memory, third, I/O. So these are the most part of our operating system. I think that this one is half of the semester. And the 30%, 20%, like this. Okay, to start the process management. Where is my here? Finally. Okay. So I think we have 3 minutes because of the delay. So this one. What is the process? Let me switch. So what is the process? You heard a lot, and you are using many time. My process is not working. My process is too many processes on my laptop. What is a process?
A
Program?
series of steps.
Series of steps. Any idea? In mind, it's a data structure. So to understand as a computer science student and the professor point of view, to understand the process, what is a process? It's a data structure, which means eventually computer will use this process, create the process or whatever that. So through the process, we are going to use the computer resource. the only way to use the computing resource from the user as a Homo sapiens, they cannot understand natural language, they cannot understand my feeling or the yearly. Instead, only through the data structure. It's a kind of the protocol. It's a rule for the communication between computer and me. So somebody designed such a data structure to use the computing resource. Who? Who designed that?
Yeah, OS.
OS? Yes. OS is based on what?
Between C, C++.
CPU, processor. So processor, the Intel, when they develop the new processor, CPU, they provide all the specification and plus what? Instruction. So using that instruction, and they also provide when you are going to use the resource, the CPU. So in your memory should be like this one. There's a very firm the rule to follow. So it should be initially 32K size on the memory. And the starting 000 is a relative address. Okay, 32K. Then the first part, the 1K is used for your programming. You need to use only 1K for the programming. So your program, the main, the our file should be copied here. And 1K plus 1 by 2, the 2K will be used for the global data. If you have the global variable, you should put over here like that. It's a clearly designed. Then who should use this structure?
Your program.
Compiler. Compiler is a program. You don't know. Ever seen this kind of rule? No, never.
No.
But it works. How? Because compiler is in charge of that.
Alright.
When you compile the program is not just the instruction, the series of instruction. Actually, it knows, compiler knows such a rule, guideline, data structure of your process. That is the reason. Even though you are compiling exactly same code, but different, the CPU, like the AMD or Intel, you should compile differently, using different compilers. Because each compiler knows the specification of the data structure. Right? Following this one, when you compile the source code into this one, it understands actually this. So next time, when the loader load into the memory, just you have to follow this rule. This is a whole data structure. So we are going to see how they are organized. So for example, like this one. So this is the details of the more details. This is starting from the code main.o is here. If you have any library linked is the next one. And if you have the global variable like the integer y100, so over here, and the heap and the stack, heap is usually used for what? Dynamic pointer. Because this space is not big enough. So pointer will be used for the address, location of other memory. Okay, and also this one,
Stack.
stack is first in also,
Yeah.
right? So that means, so a lot of program has the block, like this.
Yes.
Once this one is done, we are not going to use this, right? So to the maximize the utilization, so this one is exactly fit to the stack. So stack will be used for such a the main. It's the start from the always is the main function, right? Outside. So main is here, and next the sub function will be located, reside on this. Who decide this kind of rule? CPU, then the compiler, understand, and the format, the source code that fit to this process, the data structure, finally link can load into your memory. Then CPU, because the CPU just follow whatever their rule, it follow. So just they know, the CPU know where is the data, how to get the data, and so on. If this one is AMD but the CPU is Intel, totally different. That's the reason it doesn't work. Okay, so next class we will see more details of such a data structure. Okay, let's check any question from the online student. Let me start. down here.